Hello students, in this video we are going to use the DEPT-13C NMR technique to distinguish between cyclohexanol and hydroxymethylcyclopentane, which are two constitutional isomers, okay, same molecular formula, okay, both are alcohols with different structures, okay. Now why do we want to use this DEPT technique is because if it's a normal 13C NMR, it is unable to distinguish between these two constitutional isomers. Why is that? Both show 4 peaks at similar chemical shifts. Both have a single alkoxy carbon peak and 3 other sp3 alkyl carbon peaks. So, look at cyclohexanol on the left, hydroxymethylcyclopentane on the right, okay. So we cannot distinguish them using, it's very difficult to distinguish them using the traditional 13C NMR and also in the absence of a proton NMR, okay. We have to rely on the DEPT 13C NMR to distinguish between these two constitutional isomers. So what is the DEPT-13C NMR? DEPT NMR helps distinguish between different types of carbon atoms, CH, CH2, CH3 and C, okay, by analyzing the phase and intensity of the signals. The 3 principal types, VID45. This experiment shows all the protonated carbons, CH, CH2 and CH3 with positive up signals, okay. Unprotonated C atoms do not show up, okay. In DEPT-90, in this experiment, only signals from the CH carbon are observed as positive up signals. When I say positive signal means signals pointing in the up direction, okay. Unprotonated C atoms, okay, CH2 and CH do not show up in this DEPT-90. And DEPT-135, this experiment shows positive signals for CH and CH3 carbons as well, okay. But it shows a negative down signal, downward pointing direction, down signal for the CH2 carbons, okay. Unprotonated C atoms once again do not show up here also, okay. So which DEPT technique we have to use for cyclohexanol and hydroxymethylcyclopentane? We know that the DEPT-90 shows only the CH as up peaks, okay. We know the DEPT-45 depicts CH, CH2 and CH3 as up peaks, okay, whereas the DEPT-135 depicts CH and CH3 as up peaks and CH2 peaks as down peaks, okay. Of these, only the DEPT-90 and the DEPT-135 techniques are going to be useful in our case. And why is that? This is because both molecules contain only CH2 and CH type carbons, and therefore the best technique to distinguish them would be the DEPT-90 and DEPT-135 13C NMR. You see, all right. So that's why we are going to use these two techniques to distinguish the molecules. So how will we use the DEPT-90? See, both molecules in DEPT-90 only the CH peak is going to come. Okay, I have highlighted the CH peak here, or the CH carbon here, in the bold dot. Okay, so remember both will show only one peak, but the chemical shift will be different. Why is that? Look very closely. In cyclohexanol, the CH is connected to an hydroxyl group, so which means it's an alkoxy carbon and its chemical shift will be around 70 parts per million. Whereas in hydroxymethylcyclopentane, it's a normal tertiary CH carbon, right? Hydrocarbon type. And so what's going to happen? That's going to come upfield at around 30 to 40 ppm. So this way you can, distinguish between these two molecules using the DEPT-90. Now we can also use the DEPT-135 just by looking at the carbon to which the hydroxyl group is attached, okay. For hydroxymethylcyclopentane on the right, the alkoxy peak is a down peak because it's attached to CH2 carbon, right? You see that? Whereas for cyclohexanol, the alkoxy peak will be around 70 ppm, okay, will be an up peak. It will not be a down peak because it's attached to CH carbon type, CH type, right? So there will be an up peak here and there will be a down peak here, okay. So this way you can also use the DEPT-135 to distinguish both these molecules. Thank you. Have a nice day. Bye.